So guys, the numerical which we are going to sort out right now would require your thorough knowledge about arithmetic progression. And obviously, since we are dealing with solutions of triangle, then we have got to know sine rule, cosine rule, projection rule also. Alright, so let's get into the numerical and then I would again come for conclusion. Alright, let's get into this numerical which is from trigonometric function and solution of triangles. Okay, the sum says in triangle ABC, if cot A, cot B, cot C are in arithmetic progression, mind you, AP, then show that A square, B square, C square are also in AP, arithmetic progression. Obviously, when we are dealing with this type of numerical, AP involved, so we have got to know something about AP. All those, we have got to revive our AP data from gray matter. Alright, okay. And the other aspect is we have also got, since we are into solution of triangles, so we are supposed to know cosine rule, projection rule, sine rule. We may use any of those. Alright, okay. So to begin with, let's get into AP formulae and all those parameters required for this numerical. Let's get into it. Alright. So AP, whenever we talk about AP, obviously this is the example 1, 5, 9, 13, 17. It instantly flashes. That is the difference. D is the same. Now the example that I have chosen over here the difference is 4. Alright, okay. So the difference is 4. Now this is a general formula that we use for AP term to find the term. Alright, okay. So this is the formula AN, where N is the nth term. This is first term, N minus 1 into D. Alright, okay, let's straight away get into getting this. So for first term, 1 plus, it is the first term, so N substitute 1. 1 minus 1 is 0. 0 into 4 is 0, so first term is 1. For second term, again, the first term is 1. First term is 1 plus n term, it is the second term, so 2 minus 1 into 4, so 4 plus 1 is 5. Third term, identically 1 plus 3 minus 1 into 4, 4 to 8 plus 1 9, and so on and so forth. Alright, so this is the formula that we applied for AP. Okay, numbers that we got is 1, 5, 9, 13, 17, and so on and so forth. Okay, now I just assign it to be A, B, C, D, E. This is the basic part. Now the thing that we are going to apply to our numerical, let's get into it. Alright, now see, something very interesting which you may be aware or maybe you are knowing it now. Anyway, beware. See, I took this term, added it. What did I get? I get 10. And what was 10? It was 2 into this. Alright. Again I took this term plus this term. 5 plus 13 is 18. What is 18? 18 is twice that of midterm. Again, if you go ahead with this plus this would be 26. What is 26? 2 into the midterm. Alright. So we can set up a situation where we can say that first term plus third term, T belongs to term, is equal to 2 into second term, that is the middle term. What I mean is middle term. Alright, so this, keeping these things in mind, let's progress with the numerical. Alright, okay, so in continuation with this, let us progress. We have cot A, cot B, cot C, 3 numbers. Alright, and we are saying that these numbers are in AP. So this rule has to be followed. Alright, so what's that rule? Just let's write that. So first term, this is the first term, this is the third term, and this is the middle term. So obviously cot A plus cot C should be equal to twice cot B. Right, same thing that we are applying. So let's break it up. Cot we know is cos over sine. So it would be cos A over sine A plus cos C over sine C is equal to 2 cos B over sine B. Alright, obviously we are into solution of triangles, so let's get into this. So if we check out over here, what would it be if we take this there, this there? Okay, let me do that. If we take this there and this there, it would be b square plus c square minus a square. Alright, so done. Then for cos A, 2bc would come down, 2bc. Alright, so similarly, so this would be for cos A. Similarly, even for this, we can do it like that only. So when it is, we are talking of c. So in that case, what happens is you have a square plus b square minus c square. You have a square plus b square minus c square and 2ab, right? So this is what is this, and let me try to put it here. Alright, so this is cos b. We are all into let me put it here. Alright, so because denominator is yet to be done, or should we do denominator first? Sine A. Okay, let's do the denominator part also. Sine A. Now we are talking about sine A. When we talk about sine A, let's get this formula. Now we know that sine A over A is equal to k. So sine A would be ak. Alright, so I write here, so this becomes very simple, ak, and this would be obviously ck. ck, side, ck, a side, c side. Alright, okay, let's come back here now. So it will be 2 into, we are talking about cos b. So it will be c square plus b square, c square plus a square minus b square. So it would be c square plus, c square plus a square, c square plus a square minus b square upon, we are talking of cos b, 2ac, alright, and this is divided by, now here what we have is sine b, so it would be bk. Alright, we just used, so we use this first, then we used this now, and then we used this, we used cosine rule, then we also used sine rule for denominator. Okay, let me put this here. So let's now understand what happens later. Okay, so now what happens is goes down, right? So this becomes b square plus c square so you get this. Now we jolly well can cancel this out. Now in case you didn't understand why do we cancel, basic thing, we just take this out as 1 over 2 k, so it becomes like alright, so just to make you understand, so this becomes like this becomes 1 over 2, alright, and this is also 2. So now this, if I take it there, this gets cancelled, right? This I'll take it there, this I will take it here, so this and this gets cancelled. I hope you understood. Alright, this was just to make you understand. Alright, so ultimately what we are left with is, so after cancellation, what we are left is this. Alright, now let's check out if anything gets cancelled. Yes, this and this gets cancelled, this and this gets cancelled, so we are left over here with 2b square, and here it is 2 into c square plus a square minus p square. Alright, so this and this gets cancelled. So let's get what we wanted. Now see, so what we end up with is, if I take b this side, so it would be 2b. Okay, let me put it this way. This b square comes here, so it is b square plus b square is equal to c square plus a square. Let's just organize it as per our requirement. So it is a square plus c square is equal to 2b square. So isn't it the same thing? So if we assume a, b, c, a square, b square, c square as 3 terms, then sum of first term plus second term is twice that of midterm. Alright, so we prove that even cot A, cot B, cot C are in AP. Right? So see, again I repeat, as I have been always doing. So as soon as you see the sum, AP very much required. Alright, then since we are doing solution of triangle, so all these things very much required. So CP used cosine rule and sine rule. In my earlier video we had used projection rule, whereas here we have used sine rule, cosine rule. Fine. So that's how you have got to do these sums. So guys, basically what did you gather from this numerical? From this numerical we gathered, since it is from trigonometric functions, so we have got to, and from mainly from solution of triangles, so we have got to have sine rule, cosine rule and projection rule in our mind. Second thing is, since this numerical was on AP, so we have got to have thorough knowledge about arithmetic progression. All those things that we have studied in maths is very much essential for us to recap, alright, and refresh, so that we can apply it whenever required. Alright, so I hope you got some lesson from this numerical, got to revive, recapitulate it and store it in your brain and proceed to next numerical. Alright.